So hi everyone, and welcome to this video on proving some properties of the standard utility function. So we're basically gonna sort of use an actual utility function example to prove the properties that we had discussed in the last video. So we discussed a couple of properties. One of those was on the non-satiation and another one being the strict convexity. So we said that by non-satiation, right? So by non-satiation, okay, we said that it implies that the partial of the utility function with respect to each good is greater than zero. So with respect to each good, that is greater than zero. Then we also said, for as long as we're in the domain of x1 and x2 greater than zero, then we also said that if the preferences are strictly convex, if the utility function is strictly quasi-concave, and that happens when 2u1 u2 u1 2 minus u1 1 u2 squared minus u2 2 u1 squared is greater than zero. So those are things we're going to sort of look for in this particular video. So let's answer each of the sub-questions as they come. So first is obtain Jasmine's marginal utility of each good. So essentially, this is basically another way of saying solve for U1 and U2, right? That's another way of saying that. So we do that by doing this. So we take the partial of your utility function, say first with respect to x1. So getting the partial of this, it's just a simple product rule. So that's 0.5 x1 raised to negative 0.5, x2 raised to 0.5, right? So x2 doesn't change, it's just multiplicative. And then x1's exponent will become negative 0.5 as we bring down 0.5. Simplifying this, we get 0.5 x2 raised to 0.5 over x1 raised to 0.5. And since x1 is positive and x2 is positive, right? That's the domain. This is greater than zero, right? So that's for u1. So this is your u1 or your marginal utility for good one. Your u2 will be partial of u, x1, x2. With respect to x2, this should be equal to 0.5 x1, 0.5 x2 raised to now negative 0.5, right? Now negative 0.5. Then simplifying this, we get 0.5 x1 raised to 0.5 over x2 raised to 0.5. And that's also greater than 0. And this is your u2, the one that you have there. Now, the second question basically just says, is Jasmine non-satiated? Well, the answer is obvious, right? Because these two things are greater than zero, then an additional unit of either good one or good two, none less of the other, will make the consumer better off, will make the consumer happier. So the answer is yes, since U1 is greater than zero and U2 is greater than zero for all, right? X1 greater than zero and X2 greater than zero, then, okay, the consumer is non-satiated. Okay, that's how we sort of formulate our answer here. Okay, the next one just asks, prove that Jasmine's preferences are strictly convex. That's simple enough. Okay, so we need to get our cross partial derivatives. So remember, u1 is equal to 0.5 x1 negative 0.5, x2 0.5, u2 is equal to 0.5 x1 negative, x1 0.5 x2 negative 0.5. So let's get first the direct second order. And to do that, we just derive again u11. So that will be equal to negative 0.25 x1 negative 0. I'm sorry, negative, in this case now 1.5, x2 raised to 0.5. U2 would be, I take the derivative of U2 with respect to good 2 again. That should be negative 0.25, x1 0.5, x2 negative 1.5, right? So those are my direct second order partial derivatives. Then I can get my cross. Okay, so let's get the cross second order, right? So my cross second order derivatives would be, I have u1, 2. So I derive the first one with respect to x2 again. So I get 0.25 x1 negative 0.5, x2 raised to negative 0.5. Then u22, I'm sorry, u21, I derive u2 with respect to good 1. So that should be 0.25 x1 negative 0.5, x2 raised to negative 0.5. So this one, just again, it implies Young's theorem. Note that they're both equal by Young's theorem, right? Has to hold, right? So we have here u12 equal to u21. Okay, so that's what we have there. So we now have the things we need for the formula to prove that the preferences are strictly convex, which is basically to prove that the utility function is strictly quasi-concave. So remember, the formula is 2u1 u2 u12 minus u11 u2 squared minus u22 u1 squared, right? Then you have now 2 times u1, which is this one, 0.5 x1 negative 1. So I can sort of simplify it using a fraction, right? So this one will be 0.5 x2 0.5 over x1 0.5. Then this one is going to be u2 will be 0.5 x1 0.5 over x2 0.5. U12 will be 0.25 over x1.5, x2.5, right? Minus U11. Okay, U11 is going to be equal to, U11 is here, right? So that's negative 0.25 x2 0 0.5 rather. 0.5 all over x1 raised to 1.5, right? Times the next one squared, u2 squared. So that's 0.5 x 1.5 over x2 0.5 squared, right? So we have that there. Then minus your u22, which is a negative 0.25 x1 0.5 over x2 1.5 times this term here, although it doesn't fit already. Okay, we're gonna have here a term which is our u2 squared, I'm sorry, our u1 squared. So this is equal to x1 0.5 is here, then 0.5 x2 0.5 squared. Okay, now when you simplify everything, it should come up as something that's greater than 0. Now, how do I say this? Well, I know, okay, that just by imposing a couple of signs. So I know that U1 is positive, U2 is also positive, U12 is also positive, right? This one is going to be this is U11, this is negative, right? And this is a positive, right? This is a negative and this is a positive. Now, this entire 2 times a positive times a positive times a positive, this entire first term will be a positive, right? So if we put it with the equation, this entire thing here will be a positive. Then I have here negative times a positive, so that's a negative, but then it's minus a negative, so this thing here will be a positive. Then I do the same thing here. It's minus a negative times a positive. This will also be a positive. So something that's all positive is always greater than 0. And whatever the answer, you can simplify it yourself. You can prove that since the utility function will be strictly quasi-concave because this formula is greater than 0, then the preferences are therefore strictly convex. So that's it for this particular video, improving a couple of properties of the utility function. In the next video, we're going to start our discussion on the concept of an indifference curve. So thank you very much for your attention, and I'll see you in the next video. Thank you very much.